The history of computers. Computers have evolved remarkably since their inception, shaping the modern world in profound ways. This journey of technological advancement spans several centuries, featuring remarkable milestones and transformative innovations. Here is an intermediate-level exploration of the history of computers, capturing their evolution from early mechanical devices to the sophisticated machines we rely on today. Early mechanical devices. Abacus, circa 2700 to 2300 BCE. The abacus, one of the earliest known computing devices, was invented in ancient Mesopotamia. This simple tool consisted of beads strung on wires and allowed users to perform basic arithmetic operations like addition, subtraction, multiplication, and division. The abacus was used extensively in various cultures, including the Chinese, Greeks, and Romans. Antikythera mechanism, c. 100 BCE. The Antikythera mechanism, discovered in a shipwreck off the coast of Greece, is considered the world's first analog computer. This intricate device was designed to predict astronomical positions and eclipses for calendrical and astrological purposes. It demonstrated the advanced engineering skills of ancient Greek scientists. Napier's bones, 1617. John Napier, a Scottish mathematician, invented a manual calculating device known as Napier's bones. It consisted of rods inscribed with multiplication tables, allowing users to perform complex calculations more efficiently. Napier's bones laid the groundwork for future developments in mechanical computing. Pascaline, 1642. Blaise Pascal, a French mathematician, developed the Pascaline, an early mechanical calculator. This device used a series of gears and wheels to perform addition and subtraction. Although it had limited functionality, the Pascaline represented a significant step towards automated calculation. The birth of modern computing. Charles Babbage and the Analytical Engine, 1837. Charles Babbage, an English mathematician and inventor, is often referred to as the father of the computer. He designed the Analytical Engine, a mechanical general-purpose computer. The Analytical Engine featured an arithmetic logic unit, control flow through conditional branching and loops, and integrated memory, making it a precursor to modern computers. Although Babbage never completed a working model, his designs laid the foundation for future innovations. Ada Lovelace, the first programmer. Ada Lovelace, an English mathematician and writer, collaborated with Babbage on the Analytical Engine. She is credited with writing the first algorithm intended to be processed by a machine, making her the world's first computer programmer. Lovelace recognized the potential of the Analytical Engine to perform not just arithmetic but also complex computations, a visionary insight that anticipated the future of computing. The advent of electronic computers. Alan Turing and the Turing Machine, 1936. Alan Turing, a British mathematician and logician, introduced the concept of the Turing machine, a theoretical model that could simulate any algorithmic computation. The Turing machine provided a formal framework for understanding computation and laid the theoretical groundwork for modern computer science. ENIAC, 1945. The Electronic Numerical Integrator and Computer, ENIAC, was the first general-purpose electronic digital computer. Developed by John Presper Eckert and John Mauchly at the University of Pennsylvania, ENIAC was designed to perform complex calculations for the U.S. military during World War II. It used vacuum tubes to perform arithmetic and logic operations, marking a significant leap in computational power and speed. UNIVAC I, 1951. The Universal Automatic Computer I, UNIVAC I, was the first commercially produced electronic digital computer. Developed by Eckert and Mauchly, UNIVAC I was used for various applications, including business data processing and scientific research. Its success demonstrated the potential of computers for commercial and industrial use. The mainframe era. IBM and the mainframe revolution. International Business Machines, IBM, played a pivotal role in the development of mainframe computers. In 1952, IBM introduced the IBM 701, the company's first commercial scientific computer. This was followed by the IBM 650, which became one of the most popular mainframes of its time. IBM System/360, 1964. The IBM System/360, introduced in 1964, was a family of mainframe computers that revolutionized the industry. It featured a unified architecture, allowing different models to run the same software. This innovation reduced costs and increased flexibility for businesses, solidifying IBM's dominance in the mainframe market. The rise of personal computers. The microprocessor revolution, 1971. The invention of the microprocessor by Intel in 1971 marked a turning point in computing history. The Intel 4004, the first commercially available microprocessor, integrated the functions of a computer's central processing unit, CPU, onto a single chip. This breakthrough made it possible to build smaller, more affordable computers. Altair 8800, 1975. The Altair 8800, developed by Micro Instrumentation and Telemetry Systems, MITS, is often regarded as the first successful personal computer. It featured the Intel 8080 microprocessor and could be assembled from a kit. The Altair 8800 inspired a generation of hobbyists and entrepreneurs, including Bill Gates and Paul Allen, who founded Microsoft to develop software for the new computer. Apple I and Apple II, 1976 to 1977. Steve Jobs and Steve Wozniak co-founded Apple Computer and introduced the Apple I in 1976. Unlike earlier computers, the Apple I was a fully assembled circuit board, making it more accessible to non-technical users. The Apple II, released in 1977, was one of the first highly successful mass-produced personal computers. It featured a color display, expansion slots, and user-friendly software, establishing Apple as a major player in the burgeoning personal computer market. IBM PC, 1981. IBM entered the personal computer market with the launch of the IBM PC in 1981. The IBM PC was built using off-the-shelf components and featured an open architecture, allowing third-party developers to create compatible hardware and software. This openness fueled rapid growth in the PC market and led to the widespread adoption of IBM-compatible PCs. The Graphical User Interface, GUI, revolution. Xerox PARC and the Alto, 1973. Xerox's Palo Alto Research Center, PARC, developed the Alto, a pioneering computer that featured a graphical user interface, GUI, with windows, icons, and a mouse. Although the Alto was never commercially released, its innovative design influenced future developments in personal computing. Apple Macintosh, 1984. The Apple Macintosh, introduced in 1984, brought the GUI to a mass audience. The Macintosh featured a user-friendly interface with icons, windows, and a mouse, making it more accessible to non-technical users. Its success popularized the GUI and set the standard for future personal computers. Microsoft Windows, 1985. Microsoft responded to the growing popularity of the GUI with the release of Windows in 1985. Windows provided a graphical interface for IBM-compatible PCs, making them more user-friendly and accessible. The success of Windows cemented Microsoft's position as a dominant player in the software industry. The Internet and the World Wide Web. ARPANET, 1969. The Advanced Research Projects Agency Network, ARPANET, was the first operational packet switching network and the precursor to the modern Internet. Developed by the U.S. Department of Defense, ARPANET connected multiple research institutions and allowed them to share resources and information. The birth of the World Wide Web, 1989 to 1990. Tim Berners-Lee, a British scientist at CERN, invented the World Wide Web in 1989 to 1990. The web introduced the concept of hypertext, allowing documents to be linked together and accessed through a browser. The first web browser, World Wide Web, was developed by Berners-Lee in 1990, paving the way for the rapid growth of the Internet. The dot-com boom, 1990s. The commercialization of the Internet in the 1990s led to the dot-com boom, a period of rapid growth in online businesses and technology companies. Companies like Amazon, eBay, and Google emerged during this time, transforming the way people shop, communicate, and access information. The mobile and cloud computing era. The rise of mobile devices. The advent of smartphones and tablets in the early 2000s revolutionized computing once again. Devices like the Apple iPhone, 2007, and the iPad, 2010, brought powerful computing capabilities to the palms of users' hands. Mobile apps and services proliferated, making computing more accessible and integrated into daily life. Cloud computing. Cloud computing, which allows users to access and store data and applications over the Internet, became a major trend in the 2010s. Services like Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform enabled businesses and individuals to leverage powerful computing resources without investing in expensive hardware. The Internet of Things, IoT. The Internet of Things, IoT, refers to the network of interconnected devices that collect and exchange data. IoT devices, ranging from smart home appliances to industrial sensors, have expanded the scope of computing, enabling new applications and services across various industries. The future of computing. Artificial intelligence and machine learning. Artificial intelligence, AI, and machine learning, ML, are transforming computing by enabling machines to learn from data and make decisions. Applications of AI and ML span various fields, including healthcare, finance, and autonomous vehicles, promising to revolutionize industries and improve everyday life. Quantum computing. Quantum computing, which leverages the principles of quantum mechanics, has the potential to solve complex problems that are beyond the capabilities of classical computers. While still in its early stages, quantum computing holds promise for breakthroughs in cryptography, material science, and optimization problems. Edge computing. Edge computing involves processing data closer to its source, reducing latency and bandwidth usage. This approach is particularly important for applications like autonomous vehicles, smart cities, and industrial automation, where real-time processing is critical. Ethical and societal implications. As computing technology continues to evolve, it raises important ethical and societal questions. Issues like data privacy, cybersecurity, and the impact of automation on employment need to be addressed to ensure that technological advancements benefit society as a whole. Conclusion. The history of computers is a testament to human ingenuity and the relentless pursuit of innovation. From early mechanical devices to the sophisticated machines of today, computers have transformed every aspect of our lives. As we look to the future, the continued evolution of computing promises to bring even more profound changes, shaping the way we live, work, and interact with the world.